In this example problem, we're going to look at sensitivity, specificity, positive predictive value, and negative predictive value using a somewhat different example than we saw in class. The World Health Organization conducts surveys in countries who are trying to prove that they have achieved neonatal tetanus elimination. Now, to diagnose neonatal tetanus deaths in rural locations, women are interviewed using the oral autopsy method to try to determine if the mother gave birth to an infant that died of neonatal tetanus. It is very important to understand the sensitivity and specificity of oral autopsy method in order to obtain accurate estimates of the prevalence of neonatal tetanus deaths among all live births in a country. So before getting started on this problem, we're going to lay out some notation. We're going to define the event D plus as the event that a woman had an infant who died of neonatal tetanus, and D minus as the event that she had an infant who did not die of NT. T plus, on the other hand, is the event that the oral autopsy method concluded that a neonatal tetanus death occurred, and T minus then is the event that the oral autopsy concluded that a neonatal tetanus death did not occur. And I've cited a paper down here that shows that using data from Kenya, they've estimated that in this Kenyan population, the sensitivity of the oral autopsy method was 90%. The specificity was found to be 79%. And in this problem, we're going to assume that in the population being surveyed, that 0.1% of the women had an infant die of neonatal tetanus. So this is a very rare disease. It doesn't occur that much anymore. So it has a very low prevalence in the population. The first thing that we want to calculate is we want to know the probability that the oral autopsy method declares a neonatal tetanus death when the woman had an infant die of neonatal tetanus. So using the notation on the previous slide, this is going to equal to the probability of the testing positive given that they're disease positive. And we saw before that this is just sensitivity, and so it's equal to 90% as shown on the previous slide. Next, we want to know the probability that the oral autopsy method does not declare a neonatal tetanus death when the woman did not have an infant die of neonatal tetanus. And what is this value called? So using the notation, it's sort of the probability of testing negative given that you're disease negative. And we saw this on the previous slide. It's just specificity, and so it's 79%. So even though this is a different sort of context, we're not talking about a test as much, we're talking about this oral autopsy instrument, we still have these well-defined notions of sensitivity and specificity. Moving on, we now want to know what is the probability that a woman had an infant die of neonatal tetanus given that the oral autopsy method declared an NT death. And what is this value called? So we want to know the probability of being disease positive given that they've tested positive. And we learned in class that this is just positive predictive value. And in order to calculate positive predictive value, we need to use the formula. Specifically, we need to use Bayes' theorem. So it's the probability of testing positive, given that you're disease positive, times the probability that you're disease positive, divided by probability of testing positive, given that you're disease positive, probability that you're disease positive, plus the probability that you test positive, given that you're disease negative, times the probability of being disease negative. And now we just need to go in and plug in numbers. We know that this guy is sensitivity, which is 0.9, times prevalence, which we learned was 0.001. It was 0.1% prevalence, divided by 0.9 times 0.001 plus the probability that you test positive given that you're disease negative. That's going to be 1 minus specificity, or 1 minus 0.79, times the probability that you're disease negative. This is going to be 1 minus the prevalence, or 0.999. And plugging that into a calculator, we find that the answer to this question is 0.004, and that's going to be the positive predictive value. Moving on, we want to calculate the probability that a woman did not have an infant die of neonatal tetanus when the oral autopsy method does not declare a neonatal tetanus death. And what is this value called? We want to calculate the probability that you're disease negative given that you test negative. We know from class that this is just the negative predictive value. Using Bayes' theorem, it's equal to the probability of testing negative given disease negative times the probability of being disease negative divided by the probability of testing negative given that you're disease negative times the probability that you're disease negative plus the probability that you test negative given that you're disease positive times the probability of being disease positive. Again, we just have to identify the different elements and plug them in here. We know the probability of testing negative given that you're disease negative is specificity. Similarly, probability of being disease negative is 1 minus prevalence. Then moving on, we see that the probability of testing negative given that you're disease negative is going to be equal to 1 minus sensitivity times the probability that you're disease positive, which is just prevalence. And plugging all of these numbers into a calculator, you wind up with an answer that's 0.999. And recall that we've just estimated the negative predictive value. Now recall that we saw that the positive predictive value was 0.004, the negative predictive value was 0.999. So very low positive predictive value, very high negative predictive value. What are the implications of these results for neonatal tetanus surveillance? So we know that even though the sensitivity and specificity for this problem are reasonably high at 90% and 79%, we see that the fact that neonatal tetanus deaths are so rare in this population that without almost perfect specificity, we're going to have really, really low positive predictive value. So a vast majority of those who are identified as neonatal tetanus deaths using the oral autopsy method didn't actually die of neonatal tetanus, and we need to take that into account when we're designing a survey to estimate the prevalence of neonatal tetanus in a population.